All right, time for another draftphysics.com. Tom? Yeah, debatephysics.com also. Video presentation. It's such strange times on Earth. So, whatever. Figure I'll make a video. So I will talk a little bit about some of these. Dispar has done, some new silly experiments. And, with results that basically prove my point, frankly. And there really hasn't been any comment, and so that's worth pointing out. I suppose I might just read Brozo's comment again from 3 weeks ago, where he promised to redo the his famous lever experiment. There's just no word on where that is. But anyway, very little from the cranks to comment on. So I guess we'll just talk a little bit about physics and why I'm, quite confident that there's only you can only dissect from what exists. Now, obviously, all of these experiments should have been done by physics, and it's their bad that we don't have all of these experiments. But anyway. So let's say you were in space and you're just a thing, okay, and you're going to shoot two versions of the same thing. So you're going to have a little explosive, and in one case, you're going to be your whole mass will be one of the objects, and then the other object will be, say, something that's 100 times less massive, like a recoiling gun. And in the other case, you're going to be receiving a lot less because you're going to just shoot a bullet. Okay, so the simple truth is that, okay, in either case, I take something, let's say it's 1,000 times heavier, the gun, than the bullet. So it's a 1 to a 1,000 ratio. And I'm going to shoot it with the same device, the same explosion, the same energy. And logically, you've got to understand, well, the energy has to be conserved. You could argue that one case creates more heat than the other, but you'd have to make the argument to somehow demonstrate that to be true. But the fact is, the kinetic energy theory will say that the bullet has 1,000 joules, let's just say, it's going to be 1,000 to 1 ratio, and that the recoiling gun only has 1 joule. That's what their science says. Now, we know, I think everybody agrees, that the only thing that's going to be exchanged is momentum. So whatever happens this way, the only thing this thing's going to do is the 1 joule part, okay? So no matter whether it's the bullet or the recoiling gun, in either case, no matter which one of these two things you launch with the same energy, the same force, all I'm going to get from the perspective of this thing is the same. It's going to get the same energy in both cases. It's going to get half. It's a simple truth, okay? It's split. The energy is split between the two objects. So as the Bruce Yearney video kind of demonstrates, I can have a 4 mass and it will go 1/4 of the velocity, okay, with the same expanding rubber band or contracting rubber band as the 1 mass, and it'll go 4 velocity because the pressure will be equally divided among the participants, and so they'll get half. Each will have half of the total energy the rubber band could produce. And if I attach the rubber band to an immovable object, something that can't be moved, can't absorb any of the energy, that if I attach either one of these things, their velocity will be twice what it was. So it'd be one half in this case, and it would be 8 velocity in that case. So I think those are pretty conclusive pieces of data that tell you kinetic energy is nonsense, because it really can't do any work. It can't work in space. If I'm in space and I shoot things, I'm not going to turn a spaceship by shooting bullets out one side and recoiling guns out the other side, even though there's 1,000 to 1 difference in what kind of energy they're supposed to have. It's not going to make any difference to the spaceship. So, it's pretty hard evidence. And so, I mean, I've talked about the law of the lever, all these other cases that are also really good evidence. And so it's just a matter of, finding what will finally persuade people. Now, they're really not interested in hearing the truth or accepting the truth. So, that's where we're stuck. And like I said, it'd be nice if we had all these experiments, but we don't. It'd be nice if they just crashed the cars or did something clinical to demonstrate that somehow 4 times, it takes 4 times the energy to go twice as fast, and it takes 9 times to go 3 times as fast, and 16 times to go 4 times as fast, and 25 times the energy to go 5 times as fast. When Newton clearly said, no, it's, 1 unit of force, 1 unit of action, 2 units of force, 2 units of action. All right, so that's where we are. So, so it's probably just enough of a, why I'm confident. So that's just, part of the evidence. Like I said, the law of the lever, I could go through the other example. So I guess in that example that I just erased, okay, so if you just remember that example, if I catch that bullet, right, so I shoot the bullet out of my spaceship only gets 1 joule. The bullet has 1,000, okay. And then if I let that bullet hit a ballistic pendulum, the ballistic pendulum's only going to collect the 1 again. So in every case, there's this failure for the kinetic energy to actually do any work. Just demonstrating it's a fable. It's not a real thing. It was just suggested and stated as a fact. It was never demonstrated to be true. There was no experiments proving it. But speaking of experiments, there was an experiment that they did do in the 1730s, somewhere around there, where they dented the surface of clay, okay, with round objects. And what they found is that, yes, if I have a round object of the same size, one going twice the velocity, okay, 1 velocity, that I can, in fact, if I just dent the surface, okay, which, and obviously you can understand a round is basically all kinds of surfaces. Here at the bottom, it's kind of like a triangle in reverse, and at the sides, it's the opposite. It's like it's getting a pointed arrow. So the deeper it goes, the more it's pushing sideways. The less deep it goes, the more it's pushing down. So you just have to understand that concept, that it's easier to push stuff out of your way when you just have to push it sideways. When you have to push it down, it means you have to push it down and then sideways. So it's more work, okay? So obviously, yes, it ends up being 4 times the displacement. I mean, not 4 times the depth, but 4 times the width. Because you're expanding the width of the object, obviously. And so they consider that because it's, it's movement of clay in all directions. So you could argue, okay, so it moved 4 times the clay. But it only did it because of an advantage it had, where the fact is it has twice the energy. It's penetrating deeper. And so it's taking advantage of pushing sideways more than pushing down, where the one velocity has the disadvantage of, So anyway, so Disbar redid that experiment. Now, I've already argued this so many times that this is obviously a real physicist knows that if I put a really strong, hard point on an arrow and it penetrates into something further, I haven't proven that the arrow had more energy. I've only proven that how you deliver the energy matters. And that's all this experiment proves, that how you deliver the energy matters. Doesn't prove there's more energy. And so the simple argument would be is don't use round things. Yeah, so use something that has a flat surface and then redo the experiment. And so in his case, he was using floral foam. So I thought for sure he was going to, kind of point out how floral foam fucking fucktarded. No, that it's a good medium for testing. Now, I'd argue it's a bunch of little air bubbles with, so it's a bunch of little boards to break. So maybe it's, it's velocity sensitive. So the faster you go, the further you penetrate. But who knows, because he didn't do the experiment. So I thought for sure that he was going to post a video where he takes nice square things and lets them penetrate. And now, when it's square, you don't have to worry about this displacement argument. It's not about how much displacement there is. It's just about how deep it is. Deep is the same thing. Your displacement will be exactly the same as your depth, because you're not changing the width of the object as it goes deeper. So you don't have to worry about pouring a medium in and seeing how much displacement there is. You just measure the depth of the hole. Or you measure how far, you just put little markers on your object and just see how far it goes into the material. So, but he didn't do that. So it didn't bother. Not interested, okay, for whatever reason. So I thought that was curious. So he did the experiment. Exactly how I've complained is you can't do it. And just in a sense verified the racket experiment, the lie, the cheat, the bad physics, bad theory. I mean, it's bad theory. Anybody honest about the physics should concede it's not really a fair test when you're hitting something and both things have a different shape in total in the experiment, right? I mean, the total shape of this going twice the speed will be different than the total shape of this object, because of the fact that the one with lower velocity is obviously going to have the disadvantage of hitting mostly the flat part of the circle, and the faster mass is going to have the advantage of the sloped surfaces, more sloped surfaces. So it's obviously not a fair contest. Now anyone who cares about science should be able to concede, yeah, that's probably not the way to do the experiment. And this is probably the preferable way to do it. But no evidence that they're willing to concede to that idea of being fair to the experiment. That's a kind of an obnoxious concept to these fellas. Alright, so this poor guy did do another experiment where, it's that second one there where he broke a piece of foil. So he put a piece of foil between two books or some kind of whatever nonsense, and then dropped the objects. And with no surprise, you could argue that yes, get rid of that. The one, the object with twice the velocity would break the foil when the one with half the velocity wouldn't, because we already know that from like karate and lots of other things, that you don't need more energy, you just have to deliver the energy fast, and that'll break things. So we know that high velocity can fracture things. A little tiny pebble can break a window, and you could throw a heavier rock at a much slower speed and it'll bounce off. So we already know those rules exist. And so this is again this is the kind of argument you use against people who are deceivable. Okay, so this isn't the kind of argument you use when you really care about the truth and the physics. This is just when you're trying to deceive somebody. So what you could see from the experiment is, yes, one of them broke the foil and the other one pulled the two books. So showing that it was doing a lot of extra work because it, moved everything. So it's just, again, it's for what purpose? We already know, I think, everybody realizes that velocity does matter, but not because velocity has necessarily more energy. It's just that it works, that high velocities fracture things because the thing doesn't have time to absorb the energy. It can't spread it. So it's like a high temperature. You could have the same total amount of energy you're going to impose on something. You impose it 10,000 degrees instantaneously or quickly, the fractures. you apply it slowly, and it doesn't break, it doesn't fracture, it absorbs the energy. So it's really not, I mean, it's really kind of grammar schoolish kind of physics. And so it really shouldn't be part of this conversation, frankly. They should be above taking advantage of these kinds of circumstances. Just point out that, he could have used a lever to make both of the actions into the same action on the other side, and therefore they both would do the same thing, break it or not break it. Because you can just put the twice the velocity, half the mass here, and one velocity and a full mass here, and you'll get the same action here. Exactly the same. Same pressure, same velocity, same everything. So, and they'll both do the same work, obviously. The same action has to be the same work. Okay, it's the same force. You put a force meter over here, put a scale over here on this side of the lever. You could just watch it and measure that, yes, this is going to weigh. The one mass going twice the velocity is going to weigh the same as the, say, two mass going one velocity. Fact. Bringing us to his most recent last experiment. So I suppose I should show you that just for the hell of it. So he's dropping round ball thingy. Okay, now you could ask the obvious question: why does he have them taped together? Right? They're supposed to be falling at exactly the same rate, so that shouldn't be an issue. They shouldn't really separate from each other. So if the friction is negligible, which it should be, I mean, it should actually drill the hole much wider for the second ball, just to ensure that it doesn't create any extra friction. Just to be sure you're not going to screw it up. But instead of doing that, he actually has a washer glued on the end of it. And of course, if that's not centered to the hole, it's going to create some friction. So you got to be a little careful that you're not creating unnecessary friction. If these two balls aren't exactly lined up the way he taped them, it's extra friction, right? Because they won't have the same center, so they'll rub as they fall. So anyway, the results he got. So he's supposed to get, say if the number was 10, one would be 10 and the other one would be 20. And yeah, I know. Or one of them would be 5 and one of them would be 10. And the numbers he got are 9 and 10. So instead of 100% difference, he got a 10% difference. So you're saying, well, it's so far from his prediction. Yeah, it didn't come out. It's supposed to be, they should be both 9s or they should both be 10. So they should be the same. But it's like the Brozo experiment, 19 and 11. Yeah, it's supposed to be 20 and 10. But I would argue, well, there's errors in your experimental technique. So all he could have done, if he wanted to make the experiment more credible, I mean, obviously he can't change the results, which are terrible for their side, in the sense that it's nowhere close to twice the energy showed. 9 and 10 isn't anywhere close to 2 to 1. And on top of that, he could have shown us where it is the same. Like, how much higher did he have to lift this 2 mass? So he's doing a 2 mass at 1 unit of distance and a 1 mass at 4 units. So that means the 1 mass has twice the velocity. And looking at it, it appears to be pretty close to that. But it doesn't take much error to create some error, right? So all he had to do was just move this up a little bit, like an inch, and see how much of a difference it made. A centimeter at a time. Could have lifted it higher and see then if he can get 10 and 10. See at what point the deflection in the rubber band is the same. See how much higher he had to lift it, but he didn't do that. So it's all these, they never take these experiments and play with them a little bit to see what happens to change the results. Because they're engineered to just do one thing: try to create doubt and confusion in perfectly reasonable minds by saying, look, this experiment shows it, and you should somehow be convinced that somehow the lever doesn't work, that conservation of momentum doesn't happen, and that Newton was some sort of lunatic who thought twice the force is twice the energy or twice the velocity. Or 3 times the force would be 3 times the velocity. And somebody didn't know it was supposed to be 9 times the velocity. Okay, so anyway, it's just really bad. Really, really bad. All right, so I don't know if I need to draw that, right? So, yeah, there's no. Just saying his results are 9 to 10 instead of 5 to 10 or 10 to 20. Okay, so pretty poor showing for their side. No comments. I mean, the comment was good experiment or something, and that's it. So no chatter about another one of their decisive proofs. I think he ended the video with some sort of statement like, deal with it. Yeah. And once again, the one mass stretched the rubber band more than the two mass. Deal with it. And once again, you completely failed to meet the expectations of your prediction by a huge margin. You're a huge margin off of what your scientific prediction was. So deal with that. God, these people are just such assholes. All right, so I'm not going to go bother to find the actual Brozo comment. I think I have it somewhere, and I'll just read it. Yeah, you can, you can just listen. Something like that. Let's see. So, well, I'll pause, and then I can fix this. All right, so I've drawn just a diagram of the basic arguments. The law, the lever, okay, you put a 1 mass, 2 units of distance, a 2 mass, 1 unit of distance. It's the same force on the other side. It's going to be measured as the same force by a scale, by a force meter, by your finger. It's the same thing, okay? So a 1 mass going 2v is the same as a 2 mass going 1v. Same thing. Ballistic pendulum, 2,000 joules go in, 2 joules comes out. 99% of the momentum can be conserved. 99% of the kinetic energy won't be. So you won't be able to collect anything more than the momentum. Kinetic energy says there's a ton more energy. The faster I have this bullet go, the higher the increase in kinetic energy over the momentum, and yet they'll never show you a ballistic pendulum ever collecting even 1% more of energy more than the momentum. It never collects more than the momentum, ever. The spaceship argument, so obvious. You take the particulates and the velocity of the particulates you're ejecting, called thrust. No matter whether it's explosive or gaseous or whether it's baseballs, it just doesn't matter what the thrust is made out of. The momentum value will be, thousands of times less than the kinetic energy number given. And the fact is, the only thing the spaceship can collect as an equal and opposite reaction is the momentum. So 2,000 joules of kinetic energy go out one end, only 2 joules of motion on the other side. Clearly nonsense that kinetic energy is real and that it does work. Colliding objects, so I have a 1 mass going 4v and a 4 mass going 1/4 of that velocity, or should just say 1v. So sorry for that mistake. So it's an 8-to-2 relationship. 4 times the energy is supposed to be in the 1 mass object. You have the collision, and there'll be 0 evidence that it's anything other than just the same momentums hitting each other. 0 evidence that you can do 4 times the work with the 1 mass going 4v. It can't even win the contest. It has 4 times the energy, and yet it doesn't win the collision. I mean, it's as obvious a test as you can almost get. It's so simple and obvious. Kinetic energy can't do work. It can't ever show itself capable of doing anything. Ever. Yeah, ever. All right, so this is the Brozo. I'm just going to read his statement from 3 weeks ago. It says 2 weeks here, but whatever. Anyway, 2+ weeks. And this is this, you're going to launch things with a lever. This is the first case up there where they claim this one mass can only go 1.4 the velocity. It can't go twice the velocity. Applying the same force over here won't produce a 2 mass going 1v or a 1 mass going 2v, even though those two things will balance perfectly on a lever, a balance. It doesn't matter. They're still going to insist that somehow this 1.4 thing has to happen. Yet, when Brozo did the experiment, not even close. Okay, and so this is what he said. I have a duty to everyone to redo the experiment using the same pool balls, but this time ensuring no skidding. Okay, so I don't know what you mean by ensuring no skidding. Skidding is the good thing, not a bad thing in the experiment. And technically you want them both to not lose energy as they're rolling or moving. So no rolling means they're at least obviously not making very good contact, which means they can't be losing much energy. So frankly, the skidding is like moving more freely. So it's a good thing, not a bad thing in this case. Ideally, flying through the air would be even better, but will be possible because that sped up the half pool ball. So speeding it up just is the wrong way to say it. Obviously, you can't make it go faster. You're just taking less energy from it. But they both skidded substantially, and so it's sort of a bogus argument to make that the substantial part of the difference in the experiment was caused by the fact that the heavier ball made one rotation. It still skid most of the way. And there could also have been some skidding on the full ball too. Yeah, that's right. There obviously was. That's the whole point. It wasn't rolling consistent with the surface. It was barely rolling. Okay, it was a careless mistake for me not to even consider this possibility. Well, to me, it's not, it's obviously worthy. Everything, all variables are worthy of taking note. But to say that it's the reason why the experiment failed to produce your results is reaching. Let alone deserve it, or ensure it was observable with marks on the balls. Well, the balls were already decorated, so you could tell when they rotated. And my second repeat of the similar experiment using copper rollers, so I shouldn't even mention this experiment because it was so stupid, caused a different controversy. It wasn't a controversy. The controversy was you were really dumb to think it doesn't matter that you put all the mass on the outside of a circle or you put all the mass on the inside of the circle. Yeah, that makes a huge difference in terms of how the energy is going to be absorbed by the object. Obviously, with the mass on the outside, it can store an awful lot of momentum and a much higher velocity. When I doubled the mass by filling one with lead. All right, it is best to repeat using the exact same balls and lever, whatever. I've spent hours looking for the half pool ball, which I found only a few weeks ago, but I packed it away along with everything else in my house in anticipation of the rewire. It was proving quite elusive, so he found it. He's making it sound like he didn't find it, but he said he found it. All right. I couldn't make it again, but it was so troublesome the first time because it's a very hard material to saw through accurately and sand down to perfection. Okay, so he's just cutting the sides off of a pool ball, which is a good idea, but you still do have to make them weigh the same. I have plans to make sure it can, I guess I would just make it sure it was much lighter, and then you can just stick clay on it or something, to the parts that aren't hitting the surface. I have plans to make sure it can skid when superimpose video footage of okay, whatever that is. I have plans to make sure it can't skid. So again, then if you're rolling it, then we already know that rolling is going to be hugely disadvantageous to, the slow thing is going to run out of fuel much quicker than the thing that rolls less. I mean, it has a higher velocity. The higher the velocity, the less friction, and the less it loses per inch. So that would just be cheating, frankly. After all these conversations, we already know. So instead, launch them. Do like you did with your foil and all that stuff. Just launch them off a surface. Then superimpose video footage of examples where it is allowed to skid and show that skidding makes it go faster. So again, it doesn't make it go faster. It just takes less energy from it. Skidding good, rolling bad. All right, not slower as Goofy claimed. So I didn't claim that, so that's just a lie, but he's always lying. I brought up the subject. I was the one who pointed it out and said, well, it turns out it is, to my advantage. But I'm the one who pointed it out. Okay. We all know he will still defer to the original, though, but at least it will give everyone some proof to argue back at him. So he's claiming all kinds of crap. He's making these aspersions against my character, and he hasn't put up anything. So go ahead. I'm saying yes, please do the experiment again. And if you get anything near a 1.4 result, I'll be able to demonstrate how you cheated the fuck out of the experiment, because that's the only way you're going to make that happen, is you're going to have to cheat. And that's the truth. All right. The law of the lever is really solid physics. I don't know why you think you're going to show up now 2,000 years after Archimedes and claim he didn't have it right, because he had it right. And it's how it works. The distance correlates to velocity. There's no way around that. It's a perfect correlation. 1 unit of distance, 1 unit of velocity. 2 units of distance, 2 units of velocity. You can't deny the perfect correlation. All right. If he is right, then the results should be the same. No, they'll be even better. So he didn't get that part right either. But what I'm willing to bet, I wish you were, okay, the results will be different, and we'll have come up with some, and he'll have to come up with some garbage explanation why. So, again, we've done this, been here and done this, right? Thousands of times now, it almost seems, where all these rickety, shitty experiments where they don't consider the variables. Again, I was the one who pointed out the fact that the one pool ball was rolling a little bit. It's just such bullshit. That they can't be honest about anything. I mean, how many times have I brought up the Deschardelet bullshit displacement experiment? And do they show us the cylinder object with a flat bottom dropped into anything? Never. Okay, because that'll prove that that's a fraud experiment. All right, incidentally, the original experiment was done on a glass surface with paper markings under the glass. My thinking was to roll the balls along the smoothest surface. Yeah, and it was just fine, but the markings were of little value because you did frame rates to an end point where they hit a barrier. However, it never crossed my mind how slippery the surface was, particularly with pool balls. So again, you just make it slipperier. So you put a little bit of oil on the glass, and you're pretty much guaranteed to have a pretty frictionless surface. All right, plus I was woefully ignorant about the angular momentum aspect. So there's no angular momentum aspect. Angular momentum is the same as regular momentum. Doesn't mean anything. Of rotating objects having a bearing on the speed. So they don't have a bearing. There's no distance is distance in an amount of time. And the fact that it's angular distance doesn't change that it's twice the distance. Yes, it travels a little arc instead of a straight line. the arc is still twice the distance. It's still twice the velocity. It doesn't change anything. And I was also willfully ignorant that a skidding object actually goes faster. So again, until Michael Fulwell pointed out examples of this. So that's not even, again, it's silly to say it goes faster when the point is it loses less to friction, obviously. In most cases, like I say, in some cases, obviously a rubber tire on a road skidding can be tearing up an awful lot of rubber. Anyway, my apologies to one and all for not for being the cause of all this, but I will finally put the matter to rest ASAP. My apologies to Goofy especially, seeing as I'm going to ruin his day. I'm begging for the adventure. I'm just saying, yeah, I can't wait. Please, yes, let's see it. He's such a nice bloke. Almost wanted don't do it to him. This is just such bullshit. I should let him continue to live in ignorance. Yeah, what kind of ignorance? Every single one of these experiments points to kinetic energy failing to be able to ever show itself, to ever do any work ever beyond the work momentum does. There's just no examples of your kinetic energy being in any way useful. Okay. I almost don't anyway. Should let him continue, okay, and that I'm some genius to be the only one who made an experiment he can admire, LOL. I don't think admire is the right word. Out of all of your crappy, shitty experiments, again, it was the only one I thought was at least reasonable in terms of the theme here. You sort of got the idea. You did the quick release. You have a constant force in. The lever wasn't made out of rubber. I mean, you finally did a few things right. And yes, it was rather impressive, the idea of just sawing the sides off of a cue ball, a billiard ball, in terms of it's about as a fair way you can make a half mass as I would imagine you could be, I guess. I mean, I haven't really thought about all of it, but I mean, it does seem that you still have the same mass distribution. So it seems you're not going to change substantially because you're losing this mass in the same, locations that are proportional to the size of the cue ball. Almost. I mean, I suppose it's a little bit off, but it shouldn't be much. I mean, ideally, yeah, it'd be better to have like a wheel, a flat wheel, and then just have one that's half as wide. Something like that. But even more ideal is just take the same object that hits the lever, but it makes very nice flat contact, and just shoot it into the air horizontally and see how far it goes. That's probably even better. Alright, he can admire again soon. So, I don't know, I guess he has a weird definition of soon, because it's already past what I would say soon on my watch. We're way past soon. So, and we're getting close to, I guess we're never going to see it because it didn't come out his way. I think that's what we're pretty close to. So anyway, enough of a video and such and so forth and whatnot. Yeah, the whole atmosphere is very discouraging. I mean, the arguments are crappy. It's all this hostility, all this pettiness, and, like it's completely unreasonable for somebody to say, yeah, if you put a 2 mass on a lever one distance and you feel how heavy that is, it's going to feel like the same weight as the 1 mass at twice the distance, because it will be the same momentum. And you could do it, like I said, you could test it mechanically, okay, by connecting a force meter. And the force meter is going to say 9 pounds for the 2 mass. And then when you put the 1 mass 2 distance, it's going to say 9 pounds. It's going to read the same. And then the ballistic pendulum. I mean, all the hundreds of experiments done, and not one of them have they ever stuck a thermometer in there and see how hot it got. You know, this claim that 99% of the kinetic energy was lost as heat. That's just their excuse. There's no evidence it was lost as heat. There's no evidence anything got hot. And they just use it as an excuse. In the simple case where you have a 5 mass and you just add 10 to, 5 to it, you just drop another 5 mass on it, half the kinetic energy is lost in that case, and they claim it's heat. And where is it? Again, no evidence. All right, and then the rocket is just, there's no way around it. Obviously the thrust numbers from kinetic energy are gigantic, and yet the motion the ship gets is tiny. How can that physics make sense to you? And then like I said, the crashing blocks just make it so obvious. Something with 4 times the energy can't win a smackdown or a tug of war. We know if we just reverse the experiment and allow them to go out opposite directions, that the same result's going to happen. The thing with 4 times the kinetic energy isn't going to win the tug of war. And I'm an unreasonable asshole because I think that's pretty good evidence saying kinetic energy can't do work. If it can't win a tug of war against a sissy, against something 4 times weaker than it is, it's ridiculous. Okay. But no, you people will continue to be belligerent assholes. Not accidental assholes. You're belligerently obnoxious to reason and fairness. Obnoxious to it.